Hello and welcome to today's walkthrough of the BI application DataX. Before I begin, I'd like to highlight that the whole display functionality takes effect on an on-prem environment and the whole setup requires no exposure of confidential data to any third-party providers. As the company's privacy concerns skyrocket around implementations of AI and machine learning solutions, our tool DataX stands out as it's built to support on-prem and private cloud deployments. Just a couple of words before we dive into it so you know what you're looking at. Now, we love the metaphor that your data is like a mine and it's full of gems, but these gems are often hard to find and extract. And what we mean by data gems is, for example, reliable predictors of future behaviors, or they may be identification of potential for improvements, etc. DataX is the ultimate excavator. Using sophisticated combination of machine learning algorithms, brute force techniques, correlations, and precise evaluation, it is able to generate and analyze millions of features before it picks among them the ones you're most likely to make use of. It basically scans your data, finds relationships, establishes and evaluates features, while also building a data quality report to provide explainability. Once this is done, it takes some hours of runtime to do that. It loads it in a dashboard which allows you to monitor the results and even further train your own models. I'll show you how to do that in a minute. DataX can be loaded with all the tables from a database or multiple databases. It can be deployed on top of a click data model, as well as it can be loaded with flat files, XML, spreadsheets. The list of possible data sources goes on and on, but for the demo today, we chose to use a click application because it also has some neat visuals to accompany it. Now, the click application that we chose is this one. It's a demo application that we have built for some of our webinars. What it contains is sales, marketing data, and a bunch of visuals that display it, but that's not the important item. I'm just gonna show you how the data model looks like, because I imagine that you're very well familiar with many such data models, be it in Click or other platforms or just plain databases, doesn't matter. So yeah, in this particular case, we'll be working with the fact data. The factual data is on transactional level. Then we have marketing information, especially around events and their effect. And then we have some contracts data. So we'll be pulling data from those several tables, and I'm going to show you how the DataX tool actually maximizes the value from this raw combined data. So this is the DataX application. We usually encourage users to go through the guide. There is an application guide once they start working with it. But for now, we're just going to go ahead to it. Now, what we see is already the results of the multiple evaluations and correlations that have been done behind the scenes. So here, especially if I go to the targets and features, I see each individual bubble on the scatter plot represents a combination, a correlation combination between a potential target and all the predictors that we have. Now, what I've done that you may notice here is there is one predictor which has 100% correlation. And the reason for that is that we have artificially added it as a control feature just to illustrate the functionality. So this is a copy of a feature, or sorry, this is a copy of a target, the sales for March 2024 for the Oriental group. Now, if I select it, we can even see which ones. Yeah, so this is the sales for March 2024 Oriental. We have this target in our factual data, and then we also artificially added this feature just so we can detect if it's gonna hit the 100% correlation, and it does, because it's basically the same data just presented in a different form, like in a different table hidden somewhere there. That's how we generated it. We are not going to use this for the analytical purposes. It's just here for illustration. Now, what I'm going to do is I will be selecting the top predictable items, and I want to see those predictable items, what are their predictors. So I'm just going to highlight this level of features over here. And by the way, the blue ones are positive correlation, while the red ones are negative correlation. Negative isn't necessarily a bad thing, it's still a form of correlation that we can rely on. Now, all of those are features that have passed through all the filtrations for statistical significance and other forms of evaluation that DataX conducts on their potential features. So instead of loading this dashboard with millions of potential features, a lot of which are not gonna meet any practical utility, we have reduced the number to just the ones that really matter. And then you can also see a report of all the features that have been discarded and the reason for why they were discarded. Now, what we see from this report is that there are basically two features that are good predictors and a bunch of targets that can be predicted with them. So the targets are mostly around March 2024. So apparently there is this feature over here, because we know the one on top is artificially built. So this feature over here seems to be a very good predictor. And we can actually choose all the different targets it can predict. It can predict the sales absolute amount, or it can predict the year-over-year variance for March, or the growth for March. I'm gonna go for the highest one because it has the highest correlation. And what I'm gonna do actually is I wanna remove this feature and see this target. What else is a good predictor of this target? And I'm now presented with several more options for other items that could potentially be good predictors of this target. Now, the top one, we said it's an artificial one, but how about the rest of them? I see this one is a very high good predictor, the one that we actually started with. Then I see that the times when our customer is a physician is also a good predictor. But luckily here, I also see that there is another auto-generated feature, which is the number of customers with customer type ID 5. And then on top, I see the absolute same percent customer type is physician. So what I imagine is happening behind the scenes in the raw data is that there is a table for my customers that contains both the customer type ID and the customer type name. And I guess ID 5 is physician. And that's why I get those two different aspects of the feature. So I actually generated features for all the possibilities and I didn't discard any of them. That's how DataX works. It doesn't discard any, even evidently matching items, just so the users can still logically go through the results and establish the relationships themselves. And I see the same pattern here. Customer type hospital is repeated with customer type ID 4. So I guess 4 customer type ID just equals hospital. So I will select this guy as well. I'm gonna choose those three features, and now I have a good hypothesis. The hypothesis looks like this. I imagine that the sales amount for Oriental in March 2024 can be well analyzed by looking at those three features: the number of customers those that are physicians, the number of customers that are hospitals, and the number of client interactions of any type. That's basically it for March. Now, here I can add those features to my cart. And now I can actually remove the selection and I can browse for more features. For example, I can choose some other guys and then I'll be able to add them as well to the cart. But now those two doesn't really make sense since we already added their equivalents. So I'm just gonna go ahead and show you how you can process the data even further and train your own model. Now, actually, let me show you a couple more items that are interesting before we go to the model training. Here we have the radar analysis. This is a very useful item when you have to select from thousands of features, since it gives you a very good heart shape. It's usually heart shape. Now in this particular case it's a little skewed to the one side. This radar chart allows you to see where the myriad of potential features is focused, and in better visually detect if there are some good outliers. Outliers in that case are good items, good predictors, and you can select from them. Another approach you can use to select your targets. But now I'm gonna go forward. I will retain my original target and I will move to the model training part. Now, here it welcomes me with a message that I need to select more than one feature. And I'm just gonna get the features from my card because I already have 3 of them. And here I see, okay, now I'll be training a model on this target, which is the March 2024 sales for the Oriental product division. I have a default number of buckets. So this is all my customers will be grouped together into a number of buckets. Now this could be customers, could be something else. Now we've loaded this DataX instance with predominant focus on customer analysis. It doesn't need to be the case. Now 5 is the default number of buckets, but I will go ahead and increase that number to 6. So now I know that all my customers will be divided into 6 groups, and I can tell how they can be divided. Either each group, each bucket will contain equal number of elements, or each bucket will have equal ranges of numeric distribution, which means that some buckets may have too low of an amount of customers and may get ejected from the analysis. So I may want to have 6 groups, but if one of the groups has just 1 or 2 elements, it's not going to be considered, and I'll end up with 5. I will still go with this one because in my experience it does give the better predictions. And the last part I need to do is prepare my model. Once I do that, for the unique combination of elements that I chose, it's assigned an automatic name. That's a unique name. We're going to make sure that no other model will get this same name. And the last part is that we just go ahead and train it. Now we can do that, and I'm just going to generate new app. This functionality here actually creates our own on-demand application. This is a beautiful functionality in the Click BI platform that we utilize. It's going to generate a dedicated dashboard for the model that we just practically designed. And while we're waiting for it to load, which may take up to a minute or 2, I'm going to walk you through the last part, which is the data quality dashboard. And this data quality is a very central piece of the AI DataX is bringing in, because it gives you a good oversight of how your data's current situation is. And as most of you already know, the good AI implementation usually starts with high data quality. And if you, as potential users, have some assumptions that different parts of the data should be good predictors of your data, but they either get discarded for some reason or they do not meet the end criteria, you can ask the question, all right, why is this important part of my data that I imagine should play a central role is less significant than I imagined? And usually the answer is something like data isn't maintained well, there is some statistical insignificance, there are too many nulls in the data, or some other form of data quality is jeopardized. And you can react to this. You can actually use this tool retroactively to start off fixing the data elements that you presume should be the most important guidance in your decision-making process. So let's go back and see what happened with our application. Okay, so I had to go back and retrain the model because I noticed that the previous version had a bunch of buckets that were ejected. So what I changed was I changed the strategy to equal number of elements, and now we have a trained model over here. It took 1 more minute. So I'm just gonna go ahead and open it. Yeah, you can see my name over here. This highlights the fact that I'm the one who trained the model, so I can use it as an application. I can do whatnot with it, or I can even delete it or discard it if I don't like the results. Now, if I start from the model details, it gives me a lot of information for what is happening here. So what is the model name? This is the new name of the model. Was it successfully trained or not? If it wasn't successfully trained, it would tell me why. I see what strategy I chose, and then the list of features, and at the end here I see all the available algorithms for classification analysis that are made available here. This list can be expanded basically endlessly. Right now we have automatically enabled everything from the scikit-learn library, but you can even add your own custom classification models. Second part is the data for this model is already loaded here. So if you have another solution that you may want to go for and test it out, you can basically export the data here. It has the data generated in the form that machine learning tools already like to consume, so you can just grab the data from here. And let's move forward. Here, the first part is analysis of the feature importance. So the different algorithms give us different overview of what the importance of the features that we chose is. Now, this one evaluates that there is basically no importance here for the logistic regression. The majority of the predominant importance is stacked into the client interactions feature. So we can actually move forward from here, and I'm going to show you how you're going to run your what-if analysis. Now that the model is trained, you can actually see all the groups of the customers, and you can see the buckets based on the target measure that we selected, which is the sales amount for March 2024 for the product group Oriental. And you see the average, the lowest, and the highest amounts for this particular target for each of the buckets. So here below are the buckets. We chose a strategy of 6 buckets. So we have 1, 2, 3, 4, 5, 6. See that the default settings are basically for each of the features that we have selected. We're on the minimum, and the minimum gives us in this box to the left the predicted outcome, which is right now with those settings for our features will be falling in our bucket 1. So if I want to ask the question for how are my client interactions going to affect the expected outcome, then I simply go ahead and start sliding this counter to the right up. Now we went up to bucket 4, which is one of the more optimistic buckets. It's a little above the average. And as you can see, by the way, this minimum and maximum is reflected over here. So this is the same result as you see in the bucket. So now what if I want to see how this is going to be affected if most of my customers are hospitals? All right, I see no change there. If I drag it all the way to the right, no change there. So this is affecting my outcome less than, okay. So it's more important. Is this feature affecting us somehow? Let's check the one if physicians are our customers. It seems that those two features have even together very little effect on the results. But the feature for client interactions has a very dominating effect. And now I actually can ask the question for, all right, let's see if I have more client interactions and my customers are predominantly hospitals, less physicians, vice versa. Okay, this doesn't change it even a little bit. But what I'm taking from this analysis is that client interactions is a very good driver of the results. And we can even say regardless of what the customer type is. So the takeaway from this is if we increase our client interactions, we are more likely to increase the expected outcome for our customers. We're more likely to make them purchase more items from us, regardless if our customers are hospitals or physicians. This is how we can read this analysis over here. So if you like the walkthrough today and you want to get DataX started at your company, reach out to us today at sales@b-eye-ltd.com. My name is Tian Terziev, and thank you all for watching all the way to the end. Take care and have a great day.